Hi there, this is Jacob Nash, Precalculus Lessons, and this is a video on intervals of increase and decrease and Extrema. And this is Unit 1, Lesson 7. So now you see this is like what I do every time. Like, you think I'm doing something fancy for that intro sound? I can't really see. I just play an audio on my phone every time. I don't know. I don't really know how to do advanced editing or anything. Not like I need to, because if you're watching this and you're not me, then you're probably like the only person that's watched this. So there you go. Unless something changes, because so far I've only had like one view on every video, whatever. One day, maybe this will help someone. So intervals of, well, why did I just say that? Because I didn't feel like typing it. So intervals of increase and decrease. This is the first thing. Then after that, I'll show you Extrema. So this is kind of not going to be a super long video. And I don't think I'm going to have to draw, so it won't take long. So these are always in terms of x, and you probably learned about these both in Algebra 2, but here's a refresher. It's really simple. This one's very simple, the intervals, because when something's increasing, it's like that. When it's decreasing, it's like that. It goes down, up, increase, down, decrease, constant, flat. It's not doing anything. So that's simple. You just have to know how to state it. So for this graph, what are the intervals of increase, decrease, and constant? So f of x, even though I didn't say that's what it was, but if it was f of x, it is increasing from negative infinity. Hopefully you can see my cursor here. About the ask, get no answer. Hopefully you can, but if you can't, I'm pointing at the graph, but that's fine if you can't. So it's increasing from negative infinity to 7, and negative 7, which is that first blue piece. But then it's also increasing from 2 to infinity, the other blue piece. So the blue is increasing, and then it's decreasing from 2 to negative 2, which is the yellow. And it's constant from negative 7 to negative 2. I don't really need to do any more explanation. Hopefully you understand that. That's pretty simple. I mean, increase and decrease, I mean, I think that you've probably heard of that for years, so it's pretty simple. Extrema, if that's how you say it, maybe Extrema, but it's what this is any maximum or minimum value on the graph. Maximum means something that's up high, minimum means something that's low, and that also you probably already know. In case you didn't, that's why I said it. There's 4 different kinds that there are of Extrema that you have to know, and they can be kind of confusing, but hopefully I put this in a way that makes sense. So if you just remember these 4 things, then you'll be able to tell which one it is. After you get the hang of it, it makes sense. A relative minimum is any low point on the graph, but it can't be an endpoint. So it can be something in between the graph, but it's not an endpoint. It can't be an endpoint. A relative maximum is any high point on the graph that is not an endpoint also. So if it's relative, it can't be an endpoint, and we know what a maximum minimum are, so that's what that is. Absolute, that means the very highest or lowest. So absolute minimum, the very lowest point on the graph, and absolute maximum, the very highest. And it can be an endpoint, it can be anything. There can be more than one. Sometimes a relative minimum is also the absolute minimum, because if it's not an endpoint, then it could be a relative minimum, but if it's the lowest, it's also an absolute minimum. So let's look at this. Well, when you state the Extrema, you state it like this. The function, which in this case, let's just say f of x. F of x has a, whichever one of these that there is. Let's say it has a relative minimum at of y equals whatever it is, x equals whatever it is. Wherever the point is, you state it yx. So you kind of just like flip the points. So let's practice with this graph. Only one of them points is labeled, and we'll state that in a minute. But so let's start out with point A. point A is it a relative minimum? Well, it's not 1 or 2. See, I labeled them 1, 2, 3, 4, 5. 5 is if it's none. And it's not anything that's relative because I said that couldn't be an endpoint. A and D are endpoints. That just means it's the thing on the end. What about absolute minimum? Well, it's not an absolute minimum or maximum because it's not the very lowest or highest. So it's none. That's not even an extrema. So let's make that 5, none. Point B, we see point B, it's not the absolute lowest or highest, so it's not going to be 3 or 4. But since it is a maximum, it's a high point, that means it's a relative maximum because it's not an endpoint. If it was an endpoint, just like A, it would be none. But it is an relative maximum because, it's not good when I accidentally mix up things. Absolute, that's if it's the very highest or lowest. It's not the very highest or lowest, so it has to be relative, so it's a high point maximum. So that would be number 2. So point B is a relative maximum. Point C, that one looks like it's the very lowest, and it is. So that means it's the absolute minimum. But it's technically also a relative minimum, so I'll circle 1 too, because I said that a relative minimum is any low point that's not an endpoint, and that's what it is. So like I said, there can be more than 1, and that's what it's like for this one. D, it's the absolute maximum. It's the highest point that there is, and it can be an endpoint. But it's not a relative maximum because it's an endpoint. Because relative is never endpoint. Okay, now let's state the extrema for point D. Okay, I'm not going to write it, but I'll say it. So listen to what I say. I'm using this. And let's say that it's f of x. Okay, so f of x has a, what did we say D was? Absolute maximum. So f of x has an absolute maximum at y equals 8 at x equals 6. And there you go, that is extrema, and intervals of increase and decrease. Thank you for watching, and I'll see you on the next video.